Have you ever gazed up at the moon and wondered where it came from? This beautiful, silent companion has lit up our night sky for as long as humanity has existed. But its origin story is far more dramatic and violent than you might imagine. It's a tale of cosmic collision, a planetary smash-up of epic proportions that took place right here in our own cosmic backyard. Today, we're journeying back, in time way back, 4.5 billion years, to witness the chaotic birth of our solar system and uncover the incredible story of the day the Earth had 2 moons, and the cataclysmic event that created the one we see today. Let's set the scene. Imagine the early solar system, a far cry from the orderly place we know now. It was a cosmic construction zone, a swirling disk of gas and dust around a young, fiery sun. Gravity was pulling this material together, forming clumps that grew larger and larger. These were the protoplanets, the baby versions of the planets we see today. It was a messy, chaotic period. Think of it as a demolition derby on a cosmic scale, with these young planets constantly crashing into each other, merging, growing, and sometimes being completely obliterated. Our own planet, the Proto-Earth, was right in the middle of this chaos. It was a molten ball of rock and metal, glowing red-hot, and completely unrecognizable from the blue marble we call home. It was still growing, sweeping up debris in its path. But it wasn't alone. In a similar orbit, trailing or leading our young Earth, was another planet. Scientists have given this mysterious world a name: Theia. The name Theia comes from Greek mythology. She was the Titan goddess who gave birth to Selene, the goddess of the moon. And as you'll see, the name is incredibly fitting. Theia wasn't a small asteroid. It was a substantial world in its own right, estimated to be about the size of Mars. For millions of years, Earth and Theia shared an orbital path, dancing around the sun in a delicate but ultimately unstable gravitational tango. The laws of physics dictated that this arrangement couldn't last forever. Their paths were destined to cross, and a collision was inevitable. Picture this: 2 planetary bodies, one the size of a young Earth, the other the size of Mars, hurtling towards each other at thousands of miles per hour. This wasn't a gentle tap. This was a cataclysmic, world-shattering impact. Theia struck the Proto-Earth not head-on, but at a grazing angle. The energy released in this single event is almost impossible for us to comprehend. It was trillions of times more powerful than all the nuclear weapons on Earth combined. The impact was so immense that it would have been visible from other parts of the solar system as a brilliant flash of light. In an instant, Theia was completely obliterated, its iron core, being incredibly dense, plunged deep into the molten Earth, merging with our planet's own core. This is a crucial detail, as it helps explain why Earth has such a large and dense core for its size. The rest of Theia, along with a significant chunk of Earth's own outer layers, its mantle and crust, was vaporized and blasted into space. The collision literally peeled off part of our planet. For a brief period, Earth would have looked like something out of a sci-fi epic. It was now a much larger, hotter, and faster-spinning world, surrounded by a searingly hot ring of molten rock and vaporized debris. This wasn't a solid ring like Saturn. It was a thick, glowing torus of liquid rock orbiting our battered planet. This disk of debris was the raw material for what would come next. It was the cradle of our moon. Now, you might be thinking, this is a great story, but how do we know any of it is true? It's a fair question. This theory, known as the giant impact hypothesis, isn't just a wild guess. It's the result of decades of scientific detective work, and the clues are written in the moon rocks themselves. When the Apollo astronauts went to the moon in the 1960s and 70s, they brought back nearly 400 kilograms of lunar samples. These rocks were a treasure trove of information. When scientists analyzed these rocks, they found something astonishing. The chemical composition of the moon is remarkably similar to the composition of Earth's outer mantle and crust. Specifically, the ratios of different oxygen isotopes, flavors of the oxygen atom, are almost identical between Earth and the moon. This is a huge clue. Rocks from other parts of the solar system, like Mars or asteroids, have very different isotopic signatures. The fact that Earth and the Moon are isotopic twins strongly suggests they share a common origin. They are made of the same stuff. But there was also a key difference. The lunar rocks were found to be bone dry, completely lacking the volatile elements like water that are relatively common in Earth's rocks. They were also severely depleted in iron. This is exactly what the giant impact hypothesis predicts. The incredible heat of the impact would have boiled away any water or other volatile materials, leaving the debris disk dry. And because Thea's dense iron core sank into the Earth, the material blasted into orbit to form the Moon would have been mostly lighter silicate rock from the outer layers of both planets. The theory fits the evidence like a glove. So, let's get back to our ring of molten debris. Over a surprisingly short period of time, perhaps just a few thousand years, gravity went to work. The particles in the ring started clumping together. Small clumps attracted more particles, growing larger and larger in a process called accretion. Eventually, one dominant clump emerged, sweeping up the rest of the material in the ring. This clump was the infant Moon. Initially, this newborn Moon was a molten ball of magma, glowing cherry red in the sky, and it was much closer to Earth than it is today. If you could have stood on the surface of the primordial Earth, which you couldn't, it was a hellscape of molten lava, the Moon would have appeared enormous in the sky, maybe 10 to 20 times larger than it looks to us now. It would have dominated the view. The tidal forces between this closing Moon and the rapidly spinning Earth would have been immense. Earth's day was only about 5 or 6 hours long back then, and the Moon's powerful gravity created colossal tides, not of water, but of molten rock, sloshing across the planet's surface. Over billions of years, this intense gravitational dance has slowed everything down. The Earth's rotation has slowed to our familiar 24-hour day, and the Moon has been gradually spiraling away from us. It's still moving away. In fact, at a rate of about 3.8 centimeters per year, roughly the same speed your fingernails grow. This slow, steady retreat is a direct consequence of the conservation of angular momentum from that initial, violent collision. The formation of the Moon was not just a spectacular event. It was profoundly important for the development of life on Earth. The Moon's gravity stabilizes our planet's axial tilt. Without the Moon, Earth would wobble chaotically on its axis, leading to extreme and unpredictable climate swings that would have made it very difficult for complex life to evolve and thrive. The regular tides, driven by the Moon, created intertidal zones along coastlines, which may have been the perfect laboratories for life to make the transition from sea to land. In many ways, we owe our existence to this ancient cosmic catastrophe. The collision that could have destroyed our world ended up creating the conditions that allowed it to flourish. So, the next time you look up at the Moon, don't just see a silent, pockmarked sphere of rock. See it for what it truly is, a piece of our own planet forged in fire and flung into the heavens. It's a constant reminder of our solar system's violent past and a testament to the incredible, creative power of cosmic collisions. It's not just a satellite, it's our cosmic sibling, born from the same cataclysmic event that shaped the Earth itself. It's a part of our planet's story, hanging in the sky for all of us to see. Thank you so much for joining me on this journey back in time. It's a story that I find absolutely mind-blowing. If you enjoyed this cosmic exploration, please hit that like button and consider subscribing for more deep dives into the wonders of our universe. And I'd love to hear your thoughts in the comments below. What other space mysteries should we investigate next? Thanks for watching, and as always, keep looking up.